Hello everyone, my name is François-Jérôme Vincent, piano designer and technician based in French-speaking part of Switzerland. Today's class will focus on a major component of the grand piano, the back action. We'll begin by exploring the fundamental principle behind the design and efficiency of a well-functioning back action, with focus on the geometry of the parts and the essential criteria for optimizing performances. I will then explain the preliminary regulation I make before installing the dampers themselves, and I will show you some tools that I recommend for this work. Next, we'll move on to my step-by-step damper regulation process, designed to ensure consistent and reliable results. After that, I will present the main damper systems currently available on the markets, including those by Tokiwa, Steinway, Renner, Baldassin, as well as the latest modification introduced by C.Bechstein in their new models. We will look at the strengths and limitations of each system, including the question of whether to use spoons. To conclude, I will give an overview of the 4 pedals related to the damper: the sustain pedal, of course, the Sostenuto pedal, the Harmonic pedal, and the Steinway harmonic damper setting. So first, it's essential to consider the position of each damper lever in relation to the keys and strings. With the levers without spoons, the left-right position of the levers is determined by the key spacing only, with wider damper wire bending. However, when using levers equipped with spoons, it's possible to slightly bend the spoons to the right or left. This adjustment can reduce the amount of bending required on the damper wire itself. I won't go into the full optimization process here, but it's important to highlight the flexibility that spoons allow in positioning. Regarding the position of the damper levers in relation to the keys, this depends on the type of lever you are using. But you need also to think about the movement of the shift pedal. Typically, damper levers without spoons should be positioned slightly to the right side of the key, not centered. This helps avoid certain issues with the shift pedal. With spoons, the ideal position would be halfway between the key and the damper guide, but of course that's not always possible, especially if the spacing is too wide. It's worth noting that the key spacing is often uneven, but we still aim for consistency in the positioning of the damper levers. So we don't strictly reproduce the division of the keys, but we make it uneven. We make it even. For example, we will measure the spacing across 5 keys, then divide that value to obtain regular intervals. And we do the same every 5 keys. On my website, under the download page, you will find a PDF explaining how to carry out this operation for the keyboard capstans. The procedure is exactly the same for the keys and the dampers. You must therefore choose whether or not to use spoons. Without spoons, the damper levers ratio is higher, which makes it easier to get a 4mm lift with a damper that starts rising at half blow distance. It is often more difficult to achieve both of these conditions with these damper levers with spoons. Of course, the individual lift of the dampers can't be adjusted for each damper, except by modifying the regulation screw, but in that case it also changes the collective lift. Therefore, we can't make different regulation for the white and black keys, though it's often interesting to regulate the black keys individual lift slightly differently, as the key leverage is quite different for the sharps. The spoonless damper levers also takes up less space, which may be of interest to piano designer as it makes the soundboard surface slightly larger. With spoons, the leverage ratio is lower. The individual lift can be adjusted independently. And as we have already seen, the spoons can be bent laterally. The levers are also heavier with spoons, at least when comparing, for example, the Renner levers with the Steinway levers. But we will discuss this question later. It is also important to pay attention to the vertical movement of the damper wire when viewed from the side. While the wire does not need to be perfectly vertical, it must remain perpendicular to the damper guide rails to avoid any risk of friction in the guide rail. This alignment is usually adjusted by modifying the front-to-back positioning of the action. It's also possible to change it by modifying the position or angle of the guide rail itself, but this approach is quite tricky. In some cases, the available space is too limited to allow for any adjustment, but it remains essential to check this aspect carefully. In the back action, there are two distinct rotational movements: the movement of the damper lever and the movement of the tray, activated by the sustain pedal. These two movements occur around separate rotational axes. As we will see in more detail later, the Steinway back action does not align these two axes, resulting in two different motions. Most other manufacturers, however, tend to align them, which is also our recommendation. In the first video, the axes are properly aligned. Here you can see the movement of the lever first, followed by the movement of the tray. It's clear that the tray's movement does not affect the lever's position, which is the desired behavior, in my opinion. In the second video, the axes are not aligned. It's easy to observe that the levers moves slightly backward when the pedal is pressed. This unwanted motion disrupts the proper functioning of the damper. This type of system was originally designed to reduce the noise of the damper falling back onto the strings. While the concept may have seemed promising from an engineering perspective, in practice these back actions tend to be noisy and do not provide any real improvement in damping compared to competitors. Moreover, they make Sostenuto pedal adjustment more difficult, as the damper lever shifts backward when the sustain pedal is pressed, and pianists often use both pedals simultaneously. Now let's talk about the magic line. It's essential to take into account the magic line associated with the damper lever. That's the blue line on this drawing. First of all, let's see what a magic line is. This explanation applies to the various magic lines found in piano action, pedal levers and so on. A magic line exists whenever two parts are involved in a rotational movement and have a point of contact with each other. We can also consider a magic line when one part rotates and the other moves in translation, but this goes beyond the scope of this chapter. The purpose of a magic line is to reduce the relative movement between two parts at their point of contact. There is a magic line whenever two parts are rotating and they have a contact point. It always passes through the two rotational points and the contact point between these two parts. The magic line should only be considered for the movement where the two parts are in contact. If one of the two parts starts before the other, that part of the movement is not considered. Ideally, it should be straight halfway of the movement. It helps reduce the movement between the two parts at the point of contact. There is nothing to do with the part's horizontality or verticality. There are several magic lines in the overall piano action and keyboard, and at least one related to the dampers. This is the one we will focus on today. For more information about the magic lines in the Action Stack keyboard, you can refer to the course Piano Action Design Basics, which is also available as a podcast. As shown in this drawing, two parts are moving in rotation with a point of contact, the key and the damper lever. These parts are not in contact throughout the entire motion, but only from the moment the key begins to lift the damper. It's only this portion of the motion that we will analyze in terms of magic line. This line must be perfectly straight at the midpoint of the damper's spoon movement, which does not necessarily correspond to the midpoint of the hammer or key stroke. The movement begins when the key first makes contact with the damper lever, the blue line, and continue until the key is fully depressed, passing through the straight line, the green, halfway. On Steinway piano, as well as many other instruments, this line is not often respected. It only becomes straight at the very end of the motion or never. This leads to significant wear on the keys and felt. If you simply replace the felt without reducing this excessive sliding movement, your intervention will be nearly useless and you will need to replace it again within a few months. To better understand this phenomenon, I've created several videos. What you need to focus on is the sliding movement of the lever against the key and felt, right there. You don't even need a tool or a string. With a bit of experience, you will quickly be able to tell whether the magic line becomes straight, halfway, at the beginning, in the middle, or at the end of the motion, just by seeing if this sliding motion is very limited or excessive, like on this first video. In this first video, you'll see that the magic line appears at the very end of the stroke, as is often the case with the traditional Steinway back action. Note that for practical reasons, the demonstration was filmed outside the piano, of course, though under conditions that closely replicate the real setup. Once the damper is installed and regulated, there is a small gap between the lever and the red felt, which is not shown in this video, but this does not affect the understanding of the phenomenon. Both videos were made under the same condition with only one variable changed: the height of the back action axis lower on the second video. As you can see, the sliding movement between the two parties is quite significant in this first video. Whereas it's much more limited in the second video. For clarity, I also created a third video using a CAD drawing in which the magic line is perfectly straight. In this case, there is virtually no sliding movement between the two parts. However, it's important to note that with these damper levers without spoon, when the magic line is straight at half stroke, there is a risk that the contact point may shift at the very end of the motion from there to there. At that stage, the tip of the felt piece may become a new contact point much closer to the rotation axis. In the next chapter, we will explore how Bechstein addressed this issue by redesigning its levers in 2024. I'm referring to the gap you see here, right at the beginning, but not at the end. While it's not a problem with this setup, it can cause issues in other situations. That's why we'll show you the solution Bechstein developed to eliminate this risk. Perhaps some of you have learned the method from Rick Baldassin, Renner USA. I was asked whether their method is correct or not because it is explained differently, and one might think we are not doing the same thing, whereas in fact both methods yield a very similar result. Let's look at their picture and try to understand. In this picture from Renner USA, the key is at rest on the green felt. The damper lever is touching the key and felt, though we are in the rest position. The white straight line passes through the key fulcrum, the flange center pin of the damper lever, and the post center pin. Of course, you know that this is not how it actually is inside the piano, but the goal here is to easily find an approximate position of the lever flange's center pin. So, how will it be in the piano? The lever will be raised about 2 millimeters above the key and felt compared to this picture. As a result, this straight line will end up below the post center pin when at rest. When the key is lifted, the damper lever will cross this line about halfway to the damper's motion. More or less, the result will be the same as with the method I previously explained. So why do I explain it differently? I'd like to explain the actual effects of the magic line so that people are able to understand how it works and find the solution without having to set up anything in particular. You just need to use your eyes. Plus, it's much simpler and faster. There is nothing wrong with the Renner USA method, since the result is practically the same. It's a simple trick, just a bit slower, but to get the same result. They explain how to achieve the result, not why they are aiming for it. They don't explain what the magic line is or what it is for, but they do explain how to reach it. That's all we need. It is also important to discuss the weight that the damper system adds to the touch when the sustain pedal is not engaged and the pianist has to lift the dampers through the keys. First, I would like to emphasize that any consideration of damper weight and any possible optimization will never replace geometrical optimization. This is a slight difference compared to the rest of the piano action, where significant improvement can sometimes be achieved simply by adjusting the weight of the components. For example, proper alignment with the magic line will have a greater effect on playability than any modification of the damper weight. However, this does not prevent us from exploring this topic further. We have previously seen that the two main types of damper levers differ in width, amount of lead, and therefore in weight. Renner-style damper levers with spoons are heavier, with a strike weight at the spoon of around 15 grams for a lever with two leads, the heaviest configuration. For Steinway or Tokiwa style levers, the strike weight reaches a maximum of 11.5 grams for a lever with three small leads and goes down to 6.7 grams for a lever without any lead. To this, of course, must be added the weight of the damper head itself. We can estimate about 17 grams for a 100 millimeter long base damper, including felt and wire, but this varies significantly. When considering playability, we refer to the damper weight, which is the weight of the damper, lever, felt, and wire when the lever is horizontal and the wire is vertical. Measure at the spoon or at the contact point with the key. The damper strike weight is the weight of the damper taking into account the key leverage at the point where the damper is pushed, as shown in this diagram. In a typical piano, this leverage ratio is very close to 1, so the damper weight is nearly equal to the damper strike weight. It is important to understand that friction at the damper guide rail, as well as the resistance of the felts when lifting off the strings, especially double-wedged one, poses difficulty for the pianist, and these factors must be addressed first. We recommend homogenizing the damper strike weight to make the keyboard as even as possible. However, unlike the hammers, a specific weight curve is not particularly recommended. This depends primarily on your levers. If a customer complains about the weight of the dampers, you might consider changing the lever type and, above all, performing a very precise check of the friction points. Based on experience, adding more weight to the dampers does not seem to be very effective in improving damping quality. If there is a damping issue, it is better to focus first on the quality of regulation and installation rather than adding weight to the lever or damper heads. I do plan to publish several curves anyway for the damper strike weight in the coming weeks. When they are available, I will add the link in the video description below and on my website. I would also like to take this opportunity to mention that I will be releasing a small module in the form of an Excel spreadsheet, which will allow anyone to calculate the height of the damper lever center pin with a magic line at mid-stroke. I will also add the link in the description once it's ready. Probably this module will be included with another spreadsheet that already contains other calculations related to the action. You can find my various spreadsheets, tools, and technical documents directly on my website, pianodesign.ch. I also invite you to follow my Instagram and Facebook pages where I share some information that does not appear on the website. Thank you. Here are some key points to remember from this chapter. We saw that with damper levers with spoon, the spacing of the levers depends on the keys and the string spacing. It's possible to optimize the spacing to minimize the bending of the wires. Without spoon, the spacing of the lever depends only on the keys. I recommend using the right side of the keys as a reference point, as this will be the most relevant in relation to the shift pedal. I should also mention that I measure and recalculate the spacing of the levers based on the back of the keys without reproducing it identically, because I also aim to achieve the most regular lever spacing. For both types of levers, the axis of the flanges and tray can be aligned or not, although I personally recommend a perfect alignment. Regarding the ratio between the pedal motion and the damper lift, generally the pedal's travel is about half an inch, 12.7 millimeters at the tip of the pedal, corresponding to a damper lift of 4 millimeters. The ratio is therefore slightly greater than 3. The damper wires must be as vertical as possible in the front to back positioning, or at least perpendicular to the damper guide rail. The magic line should be straight at the midpoint of the shaft motion between the key and the lever. Let's talk now about the pre-regulation. I will begin by describing the various preliminary steps before installing the dampers. These steps are essential to achieve high quality results. I will discuss the preliminary regulation of the capstans and the Sostenuto tabs, then the adjustment of the damper levers, especially their vertical alignment and positioning. It's important to understand that the capstans are not intended to regulate the collective lift of the dampers, but to compensate for irregularities or warping in the tray. They must be adjusted so that the front of each damper lever is exactly at the same height, just like the yellow line on this picture. If the capstans are not evenly adjusted, problems will arise with the Sostenuto tabs, whose height will also be uneven. The regulation method is the same whether the capstans are in the tray or the damper levers. To choose the correct height for adjusting the capstans, the first damper must be installed and all related elements must be adjusted. The individual lift, the pedal lost motion, the pedal's dip, and the stop rail. To adjust the height of the capstan, if you have some, as well as the squareness and spacing of the levers and the height of the tabs, you can make a tool like this one. The fact that the rail is tilted backwards helps hold the damper levers against the rail, making adjustment easier and accurate. This is also the best time to adjust the Sostenuto tabs to the correct height. by placing small paper shims between the red felt and the tab, or more effectively by heating the felts to reduce their thickness. Doing this beforehand with a precisely adjusted jig like this one will save you valuable time and greatly improve the accuracy of the regulation. Later, adjusting the Sostenuto pedal will be a piece of cake. The levers must be spaced evenly and screwed at a 90-degree angle to the rail using paper shims placed behind the flanges on one side or the other. The damper levers must also be perfectly vertical. A square can be placed against the tray to give a reliable reference, but the adjustment can also be done by eye when one has enough experience. In this image, you can see that the spacing is not perfectly correct. It's better in the next photo. A few words about the damper felts. There are various qualities available on the market. What follows is a brief, non-exhaustive overview of the most common manufacturers. Few people are aware that Blitzner offers a very specific felt for their pianos. They are pre-cut and matched to each model. I don't know exactly who manufactures them, probably not the Blitzner factory itself, but as far as I know, they are the only one using this type of felt. The flat ones for the treble in particular are not stitched at the center, they are simply folded under pressure. The unicords, bicords, and double wedges are also outstanding quality. I strongly recommend using them, especially when working on a Blitzner piano. They are unfortunately quite expensive, but the results are well worth the cost. The blue felt strip is provided, you need to cut it and glue it yourself. Steinway also offers its own felt. Their horizontal fibers make them both flexible and effective, but razor fragile. They are sold pre-cut for each specific model. Tokiwa produces felt in strips, arguably among the best available in the market. Their quality makes them an excellent choice for rebuilding every piano brand. Yamaha, for its part, provides also well-crafted felts, but they tend to be too hard, especially those intended for unicord and bicord dampers. Although the cutting is precise, their hardness makes them noisy in use. Before jumping to the damper setting, here are some of the key steps to remember if you want to create your back action or to prepare it for the most perfect damper setting. You should begin by choosing the spacing of the levers based on the spacing of the back of the keys, and in the case of spoons, based on the string spacing, in order to minimize the bends in the damper wires, and of course also the back of the keys. Next, place the rotation axis of the damper tray, aligning them with the flange center pin. Then install all the levers squared in both directions and align the Sostenuto tabs using paper shims or by hitting the felts. Determine the height of the rotation axis according to the magic line and the available space inside the piano. Finally, position the rod that connects the pedal levers to the damper tray through the keybed while checking the Sostenuto pedal ratio. Your action is now ready to receive the damper wires. Now the damper setting. I will now describe the different steps involved in damper settings. I would like to emphasize once again some extremely important preliminary aspects, particularly the string level. Several tools are available, starting with this small gauge that is placed on the string wire. You will need to pull the strings or push them from underneath so that all 3 strings are at the same level. In the USA, Charles Falk also offers a small, quite practical tool that serves the same purpose. Concerning the dampers, this adjustment is very important for the bass and tenor registers, but for voicing you need to perform it across the entire piano anyway. You can either purchase or make your own string hook, like the one shown here for instance. Here are the main tools that I personally use to install the dampers on the grand piano. A bending plier, a screwdriver, a round nose or flat pliers, a hook for front to back bending, a straight and flat object such as a steel roller or a pair of scissors. In addition, I use homemade rails of various sizes that are placed on the strings to align all the damper heads with each other, and another one used to align the Sostenuto tabs. I also designed a small square that is very practical for ensuring the verticality of the damper heads and proper traveling. It's fitted with a small neodymium magnet underneath to prevent it from moving easily during regulation. It's currently available from Tafine in Belgium and Australia Piano Supply. You can use a bins bag to press down the felts and speed up the stabilization of the damper liftoff. I also use a small height adjustable tool that simulates the height of the key felt relative to the key frame, and whose thickness matches the approximate gap between the key and the damper lever when set for mid-stroke liftoff. There are also some other popular tools, such as a guide to bend the wires into the correct position, or a damper wire bending lever like this one. I personally don't use these to save time by working directly inside the piano without repeatedly removing the damper. However, if you lack experience or practice in this task, you might find them useful. You can use this spur lock damper underlever jig to adjust the damper lift. It goes below the underlever or the spoons to adjust them evenly at the same height. As you know, damper wires are supplied too long. They can only be cut once the entire back action is installed and the dampers are ready to be regulated. You start by positioning the damper lever close to its final height using the tool shown earlier on page 40. Then I gradually cut the wire, making sure not to cut it too short. I always try to keep the wire as long as possible, leaving a small clearance of about 1 millimeter inside the lever to allow for the lift regulation. I do this adjustment once per section and per felt type. Of course, not all wires are cut using this method, only the guides. Then the same length is reproduced for the other dampers of the same type and in the same section. This method depends greatly on the type of lever and the manufacturer. It's a good idea to run tests when working with new parts. I begin the regulation by setting the upper part of the wire. This upper part must absolutely be parallel to the side of the damper head. You can place a ruler around the side of the head to check the wire parallelism or use the piano's key bed. I will show this in a following video. Once resting on the strings, the head must not lean on one side, it must be vertical. In this photo you can see that the head is leaning away from the wire, which is located here on the right hand side. This means that the space between the head and the wire is too small, and you therefore need to bend the upper part of the wire to enlarge the space. The one between the two red lines here. You must work only on these two bends, as shown in this next video. In this video you can see how I check the parallelism and the parallel alignment of the wire, and how I adjust these two bends to move the wire closer or farther from the head. Instead of using a roller, you can use the front of the keypad. But on this piano it was not very practical because the polyester was very rounded. Now that the head is perpendicular to the string plane and centered over the string wire, we need to make the two bends in the damper wire. The goal is for the wire to slide freely in the damper lever when the screw is not tightened. It should not rub at all here. The wire must also be centered in the damper guide rail. In this drawing the felt is missing, but of course there is usually a cashmere red felt in that spot. The upper and lower part of the wire must be perfectly parallel. This is also why we previously squared the damper levers to ensure they are perfectly vertical. For aesthetic reasons, you should always make these bends at the same height on all wires. Some use a jig outside the piano, but to save time I prefer to do it directly inside the piano, using a visual reference point to keep the bends at the same height. In this video you can see how to do it practically. I bend the wire, then lift the lever with the wire inside to check it slides smoothly without friction. Next, you need to check that the damper head lifts simultaneously at the front and at the back side of the damper head. In this video with a side view, you can see that the back side here on your left lifts earlier than the front side. To fix this, you need to adjust the angle of the wire by tilting the wire slightly to one side or the other, which makes sense. Okay. You can even do this with the damper head still in the piano and the damper lever screw tightened, of course. Here, the problem has been corrected and the head lifts simultaneously on both sides. This is when you adjust the damper lift start point. The damper should start moving when the hammer is halfway through its strike and lift 4 millimeters. To visualize this measurement, Steinway marks a horizontal line on one hammerhead at the halfway point of the blow distance. To save time, you can use the previously mentioned tool to transfer the height of the key end felt onto the lever height, leaving a small gap of about 2 millimeters between the two. We also need to check that the damper head does not rotate when it lifts, as shown in this video. If it does, simply rotate the wire inside the damper lever, for example using pliers. I personally use round nose pliers with flat inner surfaces. Right there. Finally, you need to check the damper's trajectory. Sometimes the head shifts sideways when the damper is raised, even if it falls back correctly in the center of the string square, like a hammer shank with incorrect traveling. About the damper, this issue is mainly influenced by the upper part of the wire. It's this upper band that affects the vertical alignment of the head, while the lower band mainly determines how centered the wire is within the damper lever. Although in theory both bands contribute to both adjustments, you can therefore slightly adjust the upper band if necessary to maintain a perfectly vertical movement of the damper head. Double wedge felts should not extend much below the strings, 1 millimeter at most, and ideally they should not extend at all. As shown in this photo, hairdressing scissors can be used to trim them. When tuning grand pianos, we recommend using felt wedges rather than felt strips to avoid unnecessarily pinching the felt, which can weaken them, especially on Steinways whose felts are relatively fragile due to their horizontal fibers. I suggest watching this short slow motion video made by Scott Murphy from the Juilliard School in New York. As you will see, the felts are too long and the strings vibrate enough to touch the felt during vibration, which contributes to dampening the sound. Another reason for you to cut the felts. With double wedge felts, it's often necessary to enlarge the slit to allow the felt to open wide enough to contact the two outer strings. I simply use a small metal ruler, but you can also use a knife blade. You need to do it carefully. Regarding combined damper felts, flat and double wedged type, they can be difficult to regulate and trim. First of all, when replacing them, you must choose your felts carefully. Do not mix felts from different suppliers. The two felts must match as closely as possible. Since the double wedge types necessarily extend lower than the flat ones, they must be slightly longer, but don't forget that the flat felt compress. You must therefore first regulate your damper perfectly and then at the end trim what protrudes below the strings. In the end, they should theoretically be about 1 to 2 millimeters longer than the flat ones, considering approximately 1 millimeter of string thickness and a very slight overhang underneath, as minimal as possible. All damper heads must be aligned with each other within the same section. You can use a small wooden straight edge like the one shown in a picture previously, which you can make yourself. To do this adjustment, you need to work at the top of the wire as close as possible to the wood by adding two slight bends to push the head in one direction or another. This adjustment is influenced by the alignment of the Sostenuto tabs, and it also has a slight impact on their alignments. Therefore, it's best to perform both adjustments at the same time if you can. At the very beginning of the course, I mentioned adjusting the height of the Sostenuto tabs using a homemade jig. But during the regulation, you also need to ensure that the tabs are aligned front to back. You can change this alignment by bending the wires slightly forward or backward, just above the damper lever. The front to back alignment of the heads should be corrected at the same time, as explained earlier. To adjust the collective lift of the dampers, I recommend using a homemade tool that stops the depression of the sustain pedal at the point where the dampers just start moving. For this regulation, the Germans use the verb zappeln, which could be translated as to fidget or to squirm. It's used to describe the regulation where the dampers are squirming or wiggling in order to regulate them. Here you see a block with a capstan. Place the part with the blue felt under the pedal up against the lyre stop, and the capstan will be aligned with the front of the pedal so you can limit its travel to the point the damper heads just start moving. So they are wiggling, kind of. We will now take a look at the main back action currently available. Most of them can be ordered and installed on your pianos using the procedure we just discussed. Of course, you can also design and build your own custom back action if you wish. Let's start with the classic Renner Germany back action, found on many German pianos and widely used. It consists of two separate rails, a fixed one for the flanges, and another rotating tray that lifts the levers all together. The rotation axis are generally aligned, although this mainly affects the wear on the green felt under the capstans and makes little difference to the pianist, since the flange itself is screwed to the belly rail anyway. The capstans are in the levers, and the levers are normally with spoons. There are many screws, so assembly and disassembly take more time. However, it is possible to remove the rotating tray and replace the felt without disassembling the rest of the system, which is relatively convenient for repairs. The Tokiwa back action is used widely in repairs today, as it is of good quality and available from most suppliers. It's a single moving tray system with the flanges, which the flanges are mounted. All parts are provided by Tokiwa: the tray, unboard and too long, the felt, including pre-called felt for the stop rails, the screws, the spring, the wooden block that holds the pivots and must be glued to the tray. Capstans are not included, but you can add them yourself if you wish. The pivot pins are provided but not pre-positioned, so it's up to you to decide whether or not to align them with the flange axis. They offer two types of lever, one for new Steinways and one for older model. The difference lies in the angle of the tabs. This system can be used on many pianos. I even installed it in an old Bluthner with a patent action, and it worked very well. Unfortunately, the system has become expensive nowadays, and it costs over $1,000 US, but the quality is excellent. The original Steinway back action from Hamburg uses a single rotating damper tray with the flanges glued horizontally to the top of the tray using hide glue. This makes repair or adjustment to the levers tedious, especially when working on site and not fully disassembling the system. On American Steinways, the flanges are now screwed in vertically, somewhat like the Tokiwa back action. In both cases, of course, there are no capstans or spoons. The overall quality of the system is not that great. The spacing is uneven and proper squaring is almost never done correctly. Personally, I prefer to avoid this system whenever possible. The rotation axes of the tray are not aligned with those of the flanges. They are offset toward the rear, but not evenly. The offset is not exactly the same on the left and right side. There is also vertical misalignment, likely due to manufacturing inaccuracies rather than intentional design. As a result, the position of the levers and therefore the Sostenuto tabs changes depending on whether the pedal is engaged or not. This can lead to a situation where the Sostenuto pedal works when using the keys, but not when using the sustain pedal. The height of the rotation axis relative to the keybed differs slightly from one side to another, making it nearly impossible to precisely adjust both the individual and collective lift at the same time. The Renner USA back action, designed by Rick Baldassin, is also available to piano technician. Its main advantage is the flexibility it offers in terms of design. You can choose whether or not to use the capstans, either in the levers or in the damper tray. However, I believe installing capstans in the levers is time consuming and doesn't offer much benefit. It's better to install them directly in the tray. It's faster and simpler. The springs are included in the kit. The coil spring mounted on the tray is less convenient to install than the one from Tokiwa, because Tokiwa provides two leather pieces that make it very easy to position the spring securely and silently, which is not the case here. But it's a great system anyway. I would like to offer a comment on the C.Bechstein system, which has recently been modified. I don't know if Bechstein supplies this system for piano technician, but it's interesting to analyze its design anyway. Until now, they had been using a standard Renner system with capstan and spoons. They have now switched to a spoonless system, featuring a small rounded section, and then is the lever that allows for precise alignment with the magic line on the lever without causing any shift in the contact point at the end of the movement. This is the best possible design when not using a spoon. Recently, they also experimented with a single tray system similar to Steinway, but with the center of rotation not aligned vertically. Instead, they were aligned horizontally. The offset is therefore downward rather than rearward as the Steinway design. However, they are currently modifying this and will likely align the center pins vertically in the near future. To conclude, we'll make a few remarks about each of the pedals connected to the dampers. We will start with the sustain pedal, then move on to the Sostenuto, the Steinway Harmonic damper setting pedal, and the Harmonic pedal. Regarding the sustain pedal, on Steinway pianos, the pedal travels about half an inch at the tip with about 4 millimeters of clearance. The height of the pedal from the floor is approximately 66 millimeters. The pedal travel is first adjusted based on damper lift, which should be 4 millimeters. Specific comment now about older Bechstein pianos. The sustain pedal lever is located on the pianist's side at the front of the lyre, rather than at the back, as it's usually the case. As a result, the pedal efficiency is very high, meaning the pedal travel is short and the dampers lift very quick. This system is very noisy when the dampers fall back onto the strings, and complaints are frequent. The only solution is to move the lever toward the rear and, if possible, to lengthen it as much as possible. This significantly reduces the lever ratio and therefore the noise. The Sostenuto pedal. As for the pedal travel, it is around 15 millimeters on most pianos. Here is the long list of tools needed to regulate the Sostenuto pedal on a Steinway. Aside from the wrenches, you will notice that for some years now, at least in Hamburg, they have been using Torx screws. I will give you a few seconds to take note on this list. Another distinctive feature on Steinways is the presence of this double threaded screw called the turnbuckle. And this part is attached to the frame rather than the belly rail, right at the transition between the base and tenor section. If you turn the turnbuckle with a wrench, the rod will move up or down at that point. It's quite practical because it takes up very little space. For the Sostenuto posts, you can use those supplied by Renner. They are quite convenient, have a good geometry, and are easy to adjust. I tend to replace the provided positive screws with hex socket screws, allowing for faster and easier adjustments and disassembly. Regarding the measurements, here are Steinway's recommendation. The Sostenuto rod should be positioned at rest as shown in this drawing. It should be distant from the tabs by the value of this 1/16 of an inch square, with the rods aligned so that the corner of the rod is vertically in line with the cylindrical part, or it can protrude slightly. As for the pedal limitation, Steinway sets the damper lift higher with the Sostenuto pedal than with the sustain pedal to ensure the system works reliably. However, with a well-designed system, the damper lift with the Sostenuto pedal can be the same as with the sustain pedal. I tend to favor this method of regulation, which seems much more logical to me. The stop is adjusted on the pedal levers using capstans or felt. Regarding the stop rail, I like to set them with no play, no clearance, but without any binding. For both pedals, sustain and sostenuto, lift the dampers by the same amount, and the keys also lift the dampers by that same amount. Then everything is synchronized and there is no interference with the touch. But this requires a well-designed back action and carefully adjusted dampers. The American and German Steinways previously had a Sostenuto system mounted directly on the action stack. It was adjusted by bending the brackets up or down, or by unscrewing the screws and shifting the little brackets forward or backward. The rod is rotating using a monkey, this small wooden piece held in place by a leaf spring and attached directly to the rod. When pushed upwards by the pedal lever, the rod rotates. This system remained on Hamburg Steinway until the 80s. On American Steinways, it was replaced only in very recent years, maybe 4 or 5 years ago, with the system currently used on Hamburg piano. This new system is mounted directly onto the belly rail using the usual height and front to back adjustable brackets. The bracket located between the bass and tenor section is screwed directly onto the plate, like this. If you wish to remove the old system to install a new one, you will need to work on the plate to create a horizontal surface onto which the adjustable bracket can be screwed, and then drill holes for the two mounting screws. This is a tricky task, but it can be done if measurements are taken carefully. The new rod must be positioned relative to the Sostenuto tabs as previously described. The hole in the keybed must be slightly enlarged to allow the bolt that connects the pedal lever to the rod to pass through. The pedal lever also needs to be modified to accommodate this bolt without causing excessive noise or friction. Here is a photo of a Sostenuto lever I created for another piano. It's fairly well made with an adjustable bolt and felt inside to prevent noise. Here. The Steinway Hamburg harmonic damper setting. For now, this pedal is only available as an optional feature on piano coming from Hamburg with an additional cost of several thousand euros. It's the usual sustain pedal, but with a slightly different regulation method. Piano equipped with this adjustment are identified by a small brass plate next to the lid prop. In terms of design, there is absolutely no change compared to the traditional sustain pedal. The levers are identical, the pivot points are in the same position, the lever ratios are the same, and the lyre is identical. The only difference lies in how the dampers themselves are adjusted. This adjustment is made with the pedal depressed by an eighth of its full travel, meaning the dampers are just beginning to lift but still touch the strings. Then the strings are plugged and the goal is to achieve the same sound, the same damping quality on each string. It's somewhat the same principle as hammer string mating. To achieve the desired result, every possible element can be modified. Compromises can be made on the lift of the dampers, the felt, their length, shape. Anything can be modified. This new setting has been awarded by lovely letter and comment from the great pianist Gregory Sokolov. The harmonic pedal. Do not confuse this with the Steinway harmonic damper setting, as the two pedals have absolutely nothing in common. The idea for this pedal came from the Frenchman Denis de la Rochefoucauld, and it has been implemented in a few pianos such as Feuerich, Vanderlund and or other pianos by independent piano technicians. The principle of this pedal is the opposite of the Sostenuto pedal. When the pedal is depressed, all the dampers are lifted, but the dampers of the notes that are subsequently played fall back onto the strings while the others remain lifted. As a result, only the harmonic resonance of the note played remains. As long as the pedal stays depressed, it functions in this way, and gradually most of the dampers will fall back, which reduces the pedal's effect. It is then possible to reactivate it by pressing the pedal further up to a second notch, which re-engages the system. You can also reactivate it by lifting your foot and pressing the pedal again. The idea is based on a mechanism somewhat similar to an escapement. There are two sustain rails. The harmonic pedal rail lifts all the dampers at the level of these little levers right here. When a key is played, it causes the levers to tip back down past the rail here. There is also, of course, a rail for the sustain or damper pedal just behind it, which lifts the dampers using the capstans here. I hope you enjoyed this seminar about dampers and you are now getting used to my French accent. This is now the end. I kindly ask you not to share this video, as it meant to remain on my YouTube channel. Thank you for supporting this initiative by paying the fees on my website. Creating these videos takes a great amount of time, and your contribution allows us to keep going. You can also make a donation via our Buy Me a Coffee page, which is now available on my website or in the description below. You can find information about my work on my website, pianodesign.ch. I would be happy to answer your questions by email at the address now displayed, info@pianodesign.ch, or in the comments below. I also recommend watching my seminar on the Basics of Piano Action Design Part 1, which is also available on my website. More seminars will be available in the coming weeks or months. Many thanks. See you next time.